Hello everyone and welcome to CTL's Education Professional Development Series. My name is Amy Alcalisi, EdTech Project Manager here at CTL, and I am joined by Stephanie Shea, Marketing Manager. For those of you who are not familiar with CTL, we are headquartered in Portland, Oregon and have been providing innovative IT solutions to education and government customers for over 26 years. We are a Google for Education partner, and some of our most popular products include our brands of ruggedized CTL Intico PC laptops, convertibles, 2-in-1s, and tablets designed specifically for K-12 education. I think I might hear some background noise, so maybe if somebody could mute their microphone until we transfer, that might be helpful. Over the last 2.5 years, we've worked with Google to introduce a line of CTL Chromebooks that have been recommended by PC Magazine as the best choice for Chromebooks in education. As part of our commitment to education, CTL is offering monthly professional development webinars for our education customers. These webinars will include a variety of topics relevant to K-12 EdTech, but will have a big focus on Google Apps for education and Chromebooks in the classroom. Today's webinar is an introduction to PocketLab, presented by Robbie I think it's pronounced Duhit. Sorry, Robbie. You can help me when you get on. Director of Curriculum and Community Engagement of PocketLab. However, before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right-hand corner. You're listening in using your computer speaker system by default. If you would prefer to join over the phone, just select Telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the question pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the question and answer session at the end of today's presentation. If we run out of time, you will be contacted by your sales representative to make sure all your questions are answered. So before I'm going to move on to the next screen, before I turn it over to Robbie for our presentation, I just want to remind everyone about some resources for Nevada Ready 21 educators. When you visit the nr21.ctl.net website, you can learn about upcoming professional learning opportunities. Sign up for updates about upcoming events and information, and join our Google Plus private community for Nevada 21 educators. I would now like to introduce Robbie, the Director of Curriculum and Community Engagement at PocketLab. Before joining PocketLab, he was a teacher in Chicago and Milwaukee for 6 years, where he taught both middle school math and high school physics. Robbie will now take you through an introduction to PocketLab. So I will transfer screens over, and Robbie, please tell me how to say your last name.
It's Douthit. So it's close. You're close.
Okay, thank you.
Yeah. Yeah. Okay, so thank you for the introduction. So my name's Robbie, and I'm the Director of Curriculum and Community Engagement at PocketLab. And I'm really excited to give everyone some information about what PocketLab is and how you can use it in your classroom. So PocketLab is a wireless sensor that we use for building hands-on activities in our STEM classrooms. So for those of you who aren't familiar, STEM stands for science, technology, engineering, and mathematics, and that's what we're really focused on here at PocketLab. So I'll go ahead and take you through our presentation outline here. So first we're going to talk about what is PocketLab, and I'm going to give you a little bit of a background on our company and why we started it, and I'm actually going to have Clifton, PocketLab's inventor and CEO, tell you a little bit about why he invented PocketLab and his background. And then we're going to talk about how PocketLab can change what you're doing in your science classroom, and a little bit about some hands-on activities that we can do with PocketLab, and then I'm going to walk you through how to actually get connected and show you a quick video of a cool lab that you can set up very easily with the PocketLab and do in your classroom. And then at the end, I'll walk you through all the different resources that we have, including our free curriculum and activities that are ready for you to use in your classroom with your Chromebooks and your PocketLabs. So first we'll start out with just talking about what is PocketLab exactly. So PocketLab is a small, durable wireless sensor that easily connects to different devices like a Chromebook and allows you to collect all kinds of different scientific data. So you can collect data on acceleration and motion, magnetic fields, altitude, pressure, and temperature. All kinds of things that you would do in your science class. And because it's so easy to use and wireless, you can do all sorts of unique and interesting STEM projects that allow students to explore the world around you. Once you collect the data, you can review it and export it to programs like Google Drive for further data analysis. So with PocketLab, we're trying to bring these STEM activities to life like never before. Yep, and I'm accidentally played the video over again, so I'll just go to the next slide. So here to talk a little bit about PocketLab's inspiration is Clifton Roosboom, who's our founder and CEO of PocketLab. So I'll turn it over to him for this slide.
Hey guys, so we're really excited to be working with the Nevada Ready program, and we just want to say that we are here to support you and make you using PocketLab successful. So it came out of, the idea for PocketLab came out of some of the frustration that I had in my PhD. So what you're looking at is a picture of my experimental setup, and I studied wireless sensors. And I needed all of this equipment that you see in this picture to be able to measure what PocketLab can do in a little tiny box. So in the picture, we have computers for doing the data logging, we have instruments for making measurements, and then in that blue chamber, we were measuring temperature, pressure, vibrations. And with PocketLab, you're able to do all of that in a very simple to use product. And what this enables is hands-on learning that was only accessible to scientists, engineers before, but now you can use it with elementary students to look at collisions, middle school students to look at magnetic fields, and high school physics students to learn all the fundamentals of physics. And so PocketLab was the opportunity to take this research and apply it to something I'm really passionate about, which is science education. So that's the inspiration, and we've been it's been in development for the last 2.5 years, and we are now in 43 different countries and getting tons of different use cases. So we're excited that you guys will be using it this fall. So turning it back over to Robbie for more information.
All right, thanks so much, Cliff. So our mission here at PocketLab is up on the screen, and our mission is that we believe anyone can be a scientist, and at any grade level, any student can be a scientist, and that's what we want to enable. So we want to enable students and educators to explore the world around them like never before possible, and we want to bring those hands-on activities to life in your classroom. So why is this important? Well, abstract science concepts are really hard to understand. When you look at a slide like this, this is a typical way to talk about angular velocity of rigid bodies. Now, I'll be honest, looking at this slide makes me bored, and I really like physics. So this is challenging to engage students in complex science topics like this. So if we can bring that off of bring that to life to students with hands-on activities, we know that students learn better, and we know that students learn better in science classrooms through hands-on activities. However, if the lab equipment is too complex, we run the risk of turning students into laboratory technicians rather than the creative scientists we want them to be. And so that's what we want to help with PocketLab. We want to enable our students to be creative scientists. So I want everybody here to imagine you're in a physics classroom, and today we're going to be talking about the angular velocity of rigid bodies. So again, looking at diagrams like this doesn't seem very fun or interesting, and doesn't seem very engaging for your students. However, angular velocity is just a fancy way of saying spinning. And a spinning gymnast is a beautiful illustration of angular velocity. So if we can get our students to think about how gymnasts move and spin and tumble, we can engage them in a more interesting way. And if we take it one step further, we can do some very cool and interesting labs with PocketLab with really easy setup. So here we have our friend Cindy, and we have a PocketLab attached to her waist, just taped around her waist. And this took about 1 minute, this activity took about 1 minute to set up. And so what we can do is, as she does her cartwheels and her flips and tumbles, we're actually measuring her angular velocity with the PocketLab. And we can take that into the classroom. That's actually me doing a workshop at my old school, and students are doing investigations on rotation, and we can take it in the classroom, do other activities like magnetic fields. You can take it out of the classroom, put it inside of something like a soccer ball, and do experiments on acceleration and motion. Because we can attach PocketLab, because it's wireless and durable, we can attach it to just about anything, which makes experiments that you can do in your classroom easier to set up, and that means you're going to be able to do more hands-on activities, which means higher levels of thinking for your students and more investigation type lessons. So how exactly does PocketLab all work together with your Chromebooks and with the different software that you'll have? So PocketLab is the small wireless sensor here on the left, and in PocketLab you actually have these 5 different sensors. We have what's an accelerometer, which can measure force and motion, a gyroscope, which measures rotation, the magnetometer can measure things like magnetic fields, the pressure sensor can measure altitude and air pressure, and then we have a temperature sensor. And we can take all of this, all the scientific data that we can measure with all these different sensors, and wirelessly transmit to your device, to your Chromebook. We also work on Android phones and tablets, iOS devices, and Windows 10 devices too. So if you have students take the PocketLab home or anything like that, it can work with their phones. And then once you collect the data in our software, in our app, you can export the data to to different programs like Google Drive, where you can look at it in Google Sheets and analyze the data further, or you can export it to, or use the data to integrate with programs like Scratch, which is a visual programming language that helps students learn how to code. So you can actually do really cool activities where you can have students make like video games and use the PocketLab as like a video game controller. That's sort of an advanced use case of it that we'll go over another time. But the possibilities are really endless with PocketLab. So PocketLab is a little bit like some of the traditional education science equipment that you may have heard of. These are mostly used in high school classrooms, but you may have heard of companies like National Instruments or Vernier or Pasco, and they also make science equipment. They make sensors for science labs. But the difference between them and us is that we try to make everything very inexpensive and affordable, and we also make our product wireless and durable, so you can do different use cases with it. And because of that, and because it's so easy to use, we have a lot more middle school teachers using PocketLab, whereas a lot of these companies are used mostly in high school classrooms. There's also another set of equipment out there that's really in the maker education space. So if you've heard of companies like Arduino, Littlebits, Raspberry Pi, they make things that allow students to build circuits or code their own computer programs. And so we're kind of actually a little like both. We can do your traditional science lab experiments in a traditional setting, and we can also use PocketLab in really cool, unique ways to learn to do some more maker education projects. Like Cliff said earlier, we're in we have over 3,000 users in 43 countries, including one user who actually I actually skipped ahead. Including one user who actually brought their PocketLab to the South Pole when it was a physics teacher who was in a program that took her to the South Pole, and so she actually took her PocketLab there. Up here we're in some exhibits at a science museum where they're looking at free fall and gravity experiments. Here we have a teacher using it to do earthquake labs. So we have tons of teachers out there already using PocketLab. It's being used in museum exhibits and also just by individuals who really love science. So we have a lot of users out there that are coming up with cool and interesting use cases, sharing them with us, and we're putting them out there for everybody to use. And we'll talk about that a little bit more later. So for our presentation, we've talked a little bit about what is PocketLab and our company background and the different types of things you can do in your science classroom. And now we're going to talk about getting started with PocketLab. And we're going to do that, we're going to start by talking about, again, some of the hands-on activities you can do. So this is an example we have of a lab that we do a lot. And it works really well with middle school age students. And this activity is called the Crash Cushion Lab. So in this activity, you would attach the PocketLab to a cart and then crash the cart into a wall by having it go down a ramp. And then when it crashes, students can use the accelerometer to measure the impact force that the car felt. And then students get to then engineer and design cushions that would minimize the force of a crash. And so this actually is real-world problems that engineers do on highways and freeways. They build these cushions near on-ramps and off-ramps. So when cars crash into them, it helps save lives. So students can actually design using similar engineering concepts and then actually test their designs and get real data from it and use that to learn about things like momentum and acceleration and force. These are the objectives in that lab. Now, I'm showing you this because this is just one example of the curriculum that you'll be able to use that is free for you to download and that you can use with PocketLab, and I'll show you that how to access that at the end today. So those are the objectives for that lab, and these are some of the designs that we've seen students build. So we actually brought this to a workshop at Google where children of Google employees, it was like a Take Your Child to Work day, and these are some of, these were actually elementary school students that built these crash cushions here. So they built these, they crashed their PocketLab cart into these cushions, and then they were able to get real measurement data to see how effective their barrier was at potentially saving lives if they were to put something somewhere on the freeway. Here are some other labs or cushions that we've built. And so students are learning these engineering concepts with PocketLab. And this here is this is data that we actually collected with the PocketLab sensor. They're getting real scientific data when they're doing activities like this. And what's really cool about PocketLab, and Cliff mentioned this earlier, is the grade level, the different grade level range that you can use with it. We've had 4th graders using PocketLab and doing that crash cushion lab that I just showed you. And in that, you can scaffold it down in like an elementary setting where a teacher would do all the control trials, and then students would design their own crash cushion and bring it up, and then the teacher would do the crash test for them, and they'd be able to get their data. In middle school, you can take it up, you can scaffold it up a little bit, and look at just the one-dimensional motion of the crash, and have students test and then redesign their crash cushions, which is an engineering standard where they're testing something, redesigning it, testing it again, redesigning it, and trying to improve on their design. And then you can add an extra challenge, in high school, or if your students are doing, if a particular group in your class is doing really well, you can add an extra challenge to that exact same lab, where the different materials that they would use to build their crash cushion, you could make the different materials cost a certain amount and then give the students a budget to build a cushion, or have them try to optimize the amount of money that they would spend to build their cushion. So you can kind of add these different engineering challenges to the same activity, and really we see PocketLab being used down in 4th grade classrooms, and we also have people using PocketLab in graduate level engineering classes at Stanford and different universities across the country. So normally this kind of equipment is reserved for AP Physics in high school or college engineers, but we have tried to make it so that even students down in 4th grade can be doing similar types of complex experiments. Another really fun activity that we can do, and that will be available, the curriculum will be available for you to set it up, is stuff with air rockets and water rockets. So here we've actually attached the PocketLab to the top of this rocket, and as we launch it, we're getting the acceleration of the PocketLab at launch, and we're getting the altitude as it goes through its trajectory. So as we're, traditionally if you were going to do a rocket experiment in class, it's hard to actually gather data from it. But when you attach PocketLab, you can get all kinds of interesting data. So those are just a couple other use cases. And here are the learning objectives that you would see in our lesson that you can that you'll be able to download for free and use in your classroom. So you can look at the trajectory of the rocket. You can look at you can do some labs with Newton's laws with the rocket, learning about force and motion. And then here, this is just a screenshot, an example of the curriculum that you'll be able to get and use with PocketLab. And I'll show you where to find that later. Okay, so now I'm going to keep going with the getting started. I'm going to show you just some videos of how you can set up your PocketLab. Okay, so if you have your PocketLab with you, or if you don't yet, you can just kind of look at the screen here. But a couple of important things on the PocketLab device that are important. The first is that this is actually the front of the PocketLab. The white side is the front of the PocketLab, and the reason it's the front is because our logo here is actually the axis of orientation of the PocketLab. And you'll see it says X, Y, and Z. And what that means is when you're measuring data like on acceleration and you're measuring on the X-axis, the movement on the X-axis, Y-axis, and Z-axis, it can be a little tricky, but if you look at the logo here, it'll be really helpful. So when you move the PocketLab this way along, if you see my cursor moving, that's along the X-axis. So if you were to shake the PocketLab along the X-axis, you would see movement in that direction on the graph. If you shake the PocketLab this way, that's along the Y-axis, and you can see that from the logo. And then if you move the PocketLab back and forth this way, that's along the Z-axis. So that's something, you know, when you get your PocketLab, you can kind of play around with it, but as you're playing around with it, use that axis of orientation to help you figure out and help your students figure out which direction the PocketLab is moving. And then at the top here is the button that turns on the PocketLab, and that's the only actual button on the entire PocketLab. It's a single button. You hit the button and it'll connect with your Chromebook automatically. So, how do you get started with PocketLab? Well, the first thing you have to do is download the PocketLab app from the Google Chrome Store. So, if you go to the Google Chrome Store, you type in PocketLab, and you download it, the app. And then the second thing you want to do is make sure your Bluetooth is turned on. And so that's in the lower right corner of your screen. There's an indicator that a little icon that shows that helps you connect to the wire to like your Wi-Fi, and also it shows whether your Bluetooth is on or not. So you want to make sure your Bluetooth is enabled, and I'll show a video of this in a second as well. And then once your Bluetooth is enabled, you just open the PocketLab app and then press that button on the top of the PocketLab and bring it close to your Chromebook. And then you'll just select the PocketLab in the app and it will connect automatically. So I'll show you a quick video running through all those steps. So here I'm searching for PocketLab in the PocketLab Chrome Store. I go ahead and click on the PocketLab app. Here, I already have it downloaded, but it would say download. Right now it says launch app. Then I go and I make sure my Bluetooth is enabled. So right now it says disabled. So I go ahead and click on it and make sure that it says enabled. And I just I click, and then I click this little icon down here. And that will turn the Bluetooth on. And I can check by clicking that again, and so now it should say Bluetooth enabled, because the PocketLab will talk to your, will send data through Bluetooth to your Chromebook. And then open up the search function on your Chromebook, and you can just type in PocketLab, and the app should pop up. And now all you do is you hit the button on the top, and the PocketLab will automatically connect to the screen, or to the Chromebook. So there's my PocketLab. I click on it, and now I can just choose between all these different things that I can measure. So acceleration, pressure, altitude, magnetic field, temperature, angular velocity, and I'll show you how to get started with taking some measurements in a second. So that's how to connect to PocketLab. Okay, so next we're going to talk about how to collect data with PocketLab. And again, I'll show you a video going over this in a second as well. So first, once you're connected, you want to go ahead and just select the type of data that you want to collect. So whether that's acceleration, altitude, magnetic field, you just select that data. And then you'll be brought to a screen that'll show your data as it'll stream the data in real time. And then if you want to begin recording a set of experimental data, there's a button in the top right corner that says record. So you select the record button in the upper right corner to begin recording data, and then you simply, that record button turns into a stop button, and so you simply select stop to stop recording the data. After reviewing the data, or after you've recorded the data, you can review the data in the graph, and then you can also save the data to Google Drive. So there'll be a button that says Save to Drive. You click on that, and it automatically sends all the data to your Google account. So I'll show you a video going through that as well. So here I'm looking at the different types of data that the PocketLab can measure. And I'm going to select the data that I want to measure. So I'll go ahead and select acceleration scalar. So now I'm recording, or I'm streaming data from the PocketLab, acceleration data from the PocketLab to the Chromebook. And when I was shaking it, you could see how the acceleration data would change. I can then go back and I can try maybe pressure. So now I'm actually measuring air pressure. So you can use that to do experiments, chemistry experiments where you're measuring how pressure changes when temperature changes. You can use that to help measure altitude. There's a lot of things you can do with that. I can also measure magnetic field data. So this is kind of cool because you can measure Earth's magnetic field with it, and students can use it to do things like find north by using the data that comes off of Earth's magnetic field. You can also use it to do an experiment that we'll show a little later with electricity and magnetism. I'm going to go back just a second so that you can see how I record data. So I just click the record button, and now it's actually taking a recording of the data as I stream it. And as I move the PocketLab around, you'll see the data changing in relation to Earth's magnetic field. And then when I want to stop the data, stop my recording, I simply go up and click stop again. And then I can review the data by, when I hover over with the cursor over the different points, you can see the value of the data points below down there where it says XYZ. So as I hover the cursor over the different data points, you can get the data readings. So that's really useful for students as they're doing collections, data collections. To zoom in on data points, you simply drag the cursor over a set of part of the graph, and it will zoom in on that part. So you can zoom all the way in to just a single data point if you want, and that's helpful for students. Just by double-clicking on the screen, it'll bring you back to the full screen. I'll go back just one more second here to show you. So now I click Save to Drive up in the corner. So you'll see I'll show you one more time because it was a little quick. You click Save to Drive, and then you can save it right into your Google Drive. And then now I can go right into my Google Drive and open up the data in Google Sheets that we just collected. So there's all the data that we just collected, and then students can analyze that data and do different things with it in Google Sheets and Google Drive. Okay, so now I'm going to show you just a quick setup of a lab that you can find on our website that you can use in your classroom. And it's a really cool and interesting lab that you can set up just with your PocketLab, a 9-volt battery, a Slinky, and some wires. So what we're going to do in this lab is measure the relationship between current, electrical current, and the magnetic field generated inside a metal Slinky. And this is a really cool lab because for students to understand how electricity and magnetism are related, that can be a really hard concept for students to kind of get that those are actually the same thing. And it's really hard for students to visualize it and what exactly is happening. So what we're going to do is we're going to run an electrical current from the battery through the Slinky, and you kind of see that here too in this diagram. And as we do that, the electrical current will produce a magnetic field, and you see the direction of the magnetic field with this arrow here. And so students will be able to measure that direction and measure the magnetic field coming off of a small electrical current. So I'll show you a video of me doing that lab pretty quickly. So here's the Slinky and my 9-volt battery, and that's really all. So you don't need a ton of equipment. And then just some alligator wires and the PocketLab. And again, I'll show you where you can find this activity on our website. So you hook the alligator wires up to the Slinky so that the electrical current will run through the Slinky. And then you look at the magnetic field data. So I'm looking at magnetic field. I put the PocketLab in the Slinky, and this direction here is the x-axis, which will be shown in red here. So red is the x-axis. So if we run a current through the Slinky, we should see a magnetic field come off of the electrical current in the direction of the x-axis. So when we hook it up, we should see some change in the data that's the red graph here, because that's our x-axis. So once I hook it up, let's see if we can see a change. And there, immediately, students can see this is the magnetic field along the x direction of the PocketLab. And so that's when the current's on, right there. I disconnected it, so now it's off. I turn it back on. Then we get the change off, and there's no magnetic field. On, and there is a magnetic field. So here's current, generates a magnetic field. No current, no magnetic field. And that's a really powerful way for students to understand this force that's really invisible to them. So if you have a 6th grader, you're trying to teach them about magnetic fields, it's really hard because a magnetic field isn't something that you can look at. But here we can actually, through just a really simple experiment, we can quantify it. And now what I've done, and I'll go back just a second. So now what I'm doing is I'm switching the direction of the current. And if I switch the direction of the current, the direction of the magnetic field changes. And so the red graph was positive, and now since I've switched the direction of the current, it's negative. I can then stop the data, and here's the data we were looking at. And since it can seem like a complex set of data, but then when you can zoom in on it, you can look at all the different points, and then save that to Drive, and students can do more in-depth analysis of it. But that can be just a really simple, powerful experiment that you can do with your students to teach them how electricity and magnetic fields are connected. So next I'll just talk a little bit about the resources that you can find with PocketLab, because if you're new to using science equipment, we have a lot of resources to help you get started, and we have a lot of labs, almost 40 labs now that you can use in your classroom. We have everything set up and ready for you to use, and it's all free, and you can find it all on our website that you can download. So here are all the different labs and alignment that we have to next generation science standards. So we've worked really hard to make sure that our labs are things that you'll need to do in with NGSS. And so you'll find this document on our website as well, and you'll see it broken down in a couple different ways. But here are some of the middle school standards and high school standards. We most of our labs are in physical science, but you also see that we have some earth and space science and some engineering and technology, and we're working on some life sciences labs as well. We're also really excited to announce that we're actually working with Google to develop a PocketLab Maker Kit, and this will the kit will help you design and build hands-on experiments to explore things like motion, speed, magnetism, temperature, altitude, and more. So Google is started this Making in Science initiative. They just announced it last week, and they're also going to have what's called a Science Journal app that PocketLab will work with. So we'll have more details on that to come, but it's just something exciting that we're excited about to work with. And here's the PocketLab Maker Kit, and this will be available as well as some activities to design things like carts, pendulums, and so we'll have those instructions up on our website. But here are the different resources. So what I'm going to do is I'm going to kind of go through a couple of them. And so we have just our community page, a place for our educators where you can find all of our curriculum. Our videos page shows all kinds of videos of people using PocketLab. Our forums where you can ask and answer questions, and you can also find curriculum that other PocketLab users and teachers have made, and they post there. And then our PocketLab blog, which is just some fun stories of unique users who've used PocketLab. So I'll start by just going to our PocketLab website. So here's our PocketLab website, and that link is there on the slides. And so this just has some basic information that we've gone over, but I'll show you a couple things that are really great. So if you click on our community page, you'll be brought to our community homepage, and here you'll find all of our curriculum, all of videos, in our forum, and just a lot of resources that you can use. So the most relevant thing for you guys will probably be in the Educators tab, and that link is on the slide as well. So when you click on Educators, you'll get an overview of our curriculum, and you can see some where our curriculum is aligned to different standards. And then here, here's that crash cushion investigation, for example. So you'll be able to click on that and then download all the relevant materials for it, so you can do it in your classroom, use it in your classroom right away. Here's just some of the other, we have over 30 different activities. Here is one on building a seismometer to measure earthquakes with PocketLab. Here's something for the math teachers out there to use ratios and proportions with PocketLab to find the weight of unknown objects. It's a really cool, unique experiment. Stuff on Newton's laws, how air pressure works, pendulum motion, kinetic energy, and thermal energy. So I'll show you just briefly what it looks like when you click on one of these. So we talked a little bit about this crash cushion investigation. So when I click on that, you'll get an overview of the lesson. You'll get the NGSS alignment. This one actually has a presentation in Google Drive for you to click on, and actually has some PowerPoint slides that go with it. So I can show you that in a second. And then you just click on the different documents, and you can download all of the curriculum. And it tells you, it has everything step by step for the students to do, and how to set it up. We also have teacher guides that for the teacher to walk you through how to set everything up. So here you can also click on a teacher guide, and it will give you helpful tips of how to do the lab in your classroom, and expected data that you should see. So it'll tell you how to set it up, the expected results, some of the results we got when we tested, when we did the lab as well. And then you can go back, you can actually click on this PowerPoint slide. And this will kind of walk you through some different, this is something that you could present in your classroom when you're doing the lab to set everything up.
Robbie, this is really, really great information. We do have quite a few questions.
Yeah, that's great. So I'm just wrapping up.
And start asking a few questions.
Yeah, that's great. Yeah, that was just about it anyway. So yeah, I'm ready to take any questions that people have.
Okay, so we have Ray, and there's a few others. So
yeah,
I'll start out with, does the data have to be offloaded from the device before it is powered off, or does it remain up until the next export?
So the data, it will remain. If you disconnect the PocketLab or close the app, then yes, the data will be gone. Or sorry, if the PocketLab gets disconnected, like something happens and the PocketLab gets disconnected, the data will stay there. You can export the data that you collected. Once you close the app, though, or switch to a different sensor, then that data will be gone. So you'll want to export that data before you turn the PocketLab, before you close the PocketLab app. We are working currently on some updates to the app that would allow you to save like trials and things like that to a web interface, but that's a little ways down the road. But yeah, for right now, if you close the PocketLab app, then the data would be gone. So you have to export the data to Google Drive. Yeah.
Yeah, that makes sense because yeah. So if there's multiple Chromebooks on, right? So since the teachers get one PocketLab per 10 units, when the PocketLab the power's on, how do you know which Chromebook it will be connected to? Is there a specific name for each one, or?
Yes, that's a good question. So we're working on. So there's two answers to that. One is we're working on a way that would filter out all of the PocketLabs that are so that the Chromebook would connect only to the one that's closest. It would be able to tell the signal strength of the PocketLab. So basically, you'd be able to just put it close to the Chromebook, and it would know which one's closer and connect to that. That's still in development right now. But for right now, there's each one of them will have a different name. It'll have a serial number, and then on the bottom of your PocketLab, we're going to be putting the serial numbers on there, and so that way you can just select. So it'll show maybe 3 or 4 PocketLabs, and you select the one with the name of your serial number.
I did notice that when I linked up mine, it has a little number on there.
Yeah.
And so this device really is going to be good. It's made for really groups right now. Of course, they can always order more. So you would have one PocketLab per 10 computers, basically.
Yes.
So they can collaborate and work together.
Exactly.
It shouldn't be too much.
Yeah, so most of our teachers, the way they do it is they set up lab groups in groups of 3 to 5 students or something. So if you're in a science classroom and you have your lab groups, they may use one PocketLab per lab group. We also have a lot of teachers that use their PocketLab for demos, so they'll set up a demonstration in front of the class, and everybody will take observations of that demo. So you can also, even if you only have, you can do a lot even just with one PocketLab. And so when you have a lot of them, you'll be able to do quite a bit.
Yeah, no, these are great questions. So we have another one. Are you able to view and measure multiple data types on the same experiment run, such as measuring temp and pressure at the same time, or do you have to do those separately?
You can do two. You'll be able to turn on 2 sensors at once, but more than that, you won't be able to do more than 2. So there'll be like a 2-graph function that you'll be able to access.
Oh, okay. Is that and it shows how to access 2 at the same time?
Yeah, that'll be and that'll be an update actually that's coming. But
oh, okay. So right now they won't be able to do that, but in the future?
Yes.
Okay. I'm pretty sure that, let me see, we have like about 6 more minutes, so please ask any more questions. Or if you need someone to review, please put that if you want him to review any of his slides or how to make a connection. I know that was really helpful for me, was in our prior experience doing professional development, it was just finding on the Chromebook how to sync it, making sure everybody knew what to do, and so that was really helpful. And turning it on.
Yeah.
What kind of battery does this take?
Oh yeah, great
the simplicity of changing that out.
Yeah, so it takes a coin cell battery, so like what you'd find in a watch battery. So those are, and what's nice about that is that they last a really long time, so it doesn't take a ton of power to use. So actually, depending on the sensors that you're using, you can get anywhere from 40 hours of connected time all the way up to 100 hours of connected time. So if you're doing like the gyroscope that does the rotation, that takes up a little more power. That would take up the power a little bit more, so that would, if you had like 40 hours of that would be connected, but the temperature sensor, for example, doesn't use a lot of power, so that's why you get a little variance. But yeah, between 40 and 100 hours. So typically we see that last pretty much a whole year of lab activities, because that's 40 hours of when it's actually connected to the Chromebook, and students are connecting it and then disconnecting it and using it later and things like that. So, and then the way you replace the battery is actually, you can sort of see here on this picture, there are 2 screws here, and you just unscrew those and pop the battery out and replace it that way. So what's actually nice about that, we found, is that there's no charging. So there's no. I know when I was a teacher, when I was using Chromebooks in my classroom, and students would leave it uncharged, and then it'd be dead for the next class. So it automatically powers off when it's not connected. So it's actually really good for that.
Oh, great. That answers the question, so that's great. There's a few more questions as well. Okay. Is it waterproof, water resistant? Is it safe to put in a vacuum? And what is the furthest distance that you can be away from the computer to measure something? Like somebody noticed it was in a soccer ball. Well, if you're out on a field, how far away can you be from the connective device if it will measure the data?
Yeah, excellent question. So it's not waterproof. There is a small port in the top where the button is that we have to have an opening there for the pressure sensor, for the air pressure sensor. It is. We actually have these silicone cases that you can get from our from our website that are $9, but they cover up that port, and so the silicone case makes it a little more shock resistant and makes it a little more water resistant. We like to say that it's splash resistant with the silicone case on, but you couldn't submerge it in liquid or anything that would, because the water would be able to get in there. As far as the vacuum, yes, you can put it in a vacuum, and that's, you can do a lot of really cool air pressure experiments with that.
Measure detection.
Yeah, yeah. And then for the distance of connectivity, we can get with a direct line of sight, you can get up to 150 feet of it connected. So we've launched it up on rockets that go 100 feet in the air and it stays connected.
Oh, wow.
And on a field we've gotten about 150 feet away. So we've worked really hard to make sure that the Bluetooth antenna is good and can stay connected over a long period of time.
So it has to be connected to Bluetooth, because someone asked, can any of this be powered while offline?
Good question. So you don't have to be, you can be offline, your computer doesn't have to be online to be connected with the Bluetooth. Like it could be in, well, I don't know what it would be called exactly, but like airplane mode, for example, on a phone. You could have, you could have the Wi-Fi turned off, and it doesn't have to be connected to the internet, and it would still connect. As long as your Bluetooth is turned on, it would still connect. However, if you were with a Chromebook, if you wanted to export it to Google Drive, I think you would need a connection for that. But if you like went out of your, if you're outside, one thing you can do is have your students maybe use their phones too, and then bring the data back and send it to their Chromebook, or you could record it and bring the Chromebook back in when it's connected and export the data.
So you just answered that other question, was can this sync up to your iPhone?
Yes. And the same PocketLab can connect to any device, so it doesn't, in the app, one thing that we really like about this is that our software is free, and there's no licensing for it. So what that means is your students can download the PocketLab app on their phones, or you can download it on your phone too. And so depending on how you're using the Chromebooks in your classroom, you can connect the PocketLab to the Chromebook, use it in. If you want to take it outside, you can connect it to their phones, and there's no like limit to how many the software that they can download or anything like that. It's all just free on whatever app store you're at. So
that's great to know. That's great.
Yeah.
Because I know I've had other teachers ask, they only get 1 per 10 Chromebooks, but there's going to be some really excited coaches out there and science teachers that want to do fundraisers because they're around $75 a piece. To purchase more if they want on their own. So that answers their question. Well, we're just about out of time.
Okay.
Is there any last, anything that you want to point out besides the websites? And then I will close. Our slides.
Yeah, I would just say that we're really, really excited to support NR21. We think it's just a great initiative, and we think it's these kinds of programs are going to help a lot of students, and we just really are excited to be part of it, and we're excited to support all of our teachers, all of the teachers in any way possible. So, if you look at that resources page, I would really encourage you to go to our website, go to our community site, download curriculum, watch. There's a whole page, which I didn't get a chance to show you, with over 40 or so videos of people using PocketLab. And so if you're just looking for fun, if you're curious about different ways you can use it, check out that video page. There's a ton of different use cases there. But also, if you have any questions, I think the email was on there, contact the Pocket Lab. I actually answer all those questions, so you'll be able to ask me any question that you want, and I'm happy to answer anything. So really excited and really excited to support everybody in the program.
Well, thank you, Robbie, and thank you everyone for attending the webinar. Go ahead.
No, I just said thank you.
Yeah. I think this was really, really helpful. What a great introduction to PocketLab. I just want to let everybody know if you have any other questions, please email me. I can forward them on, or we have up here on the screen, everybody should see Robbie's email. And once you leave today's webinar, there will be a survey on the presentation, and we would appreciate it if you complete that so we can have your feedback. And don't forget to visit our nr21.ctl.net website for more news and information. You will also receive a follow-up email within 24 to 48 hours with this link to view the recording of today's webinar. So then you'll be able to skip through any part that you don't want to listen to and rewind it. So on behalf of CTL and our presenters, thank you for joining us today, and have a great day, and we appreciate all your questions.
Thank you so much.
Thank you. Bye.